Okay, Professor Garback here with part 2 of 3.3. And here we go. So that previous problem we left off at number 11. If you follow that through, you're going to get this expression. And the question does say that your answer will have and be in terms of h. Where is it? Right here. It says your answer will be in terms of h. So that means that the answer has h in it, and that's okay. That doesn't mean it's wrong or anything like that. So, moving on. Find the average rate of change, the AROC. So they want the AROC from -1 to 2. So that means we're going at interval of 3. And their function there is 6 over 2x plus 1. And so we're trying to find it from -1 to 2. So we put -1 in first, and we get 6 over -2 plus 1. So it's going to be -6. So this becomes -6. And then we put in a 2, and we're going to get 6 over 4 plus 1. So that's going to be 6 over 5. So we have to figure out, give an exact answer the problem says. So we have to go from -6 to -5 over 6. So we have to change, so this is a bunch of fractions here. So I changed the common denominator of 5. It's going to be -30 plus 6. We're doing total distance here. Okay. So we're trying to find out. So -6 to 5. So -6 to 0 is 6 units. -6 to 0 is 6 units. And then you add 6/5, and that's going to be 7 1/5. But we have to convert that, so it's going to be 36/5 over 3. So that makes it 36 over 15. So we have to be careful with changing our fractions. Just so you know, I need to know the total change from -6 to 6 over 5, so we don't subtract them. We just go the total distance between them. So there you go. So -6 to 0 is 6, and then you add 6/5 over here. Just to make a little picture of what that looks like. Here's 0, here's -6, and here's 6/5, which is here's 1. So 6/5 is out here, so they measure that total distance right here to here. Okay? That's where that's from. So a little complicated, but we got it. Next one there has another h in it, but we can handle it. It goes from interval of 8 to 8 plus h, so therefore the change from 8 to 8 plus h is obviously h, so we're dividing by h in the denominator. So the numerator is where we need to do our work, and there's a function right there, 1 over x plus 9. Okay, so we have 1 over x plus 9, we have to put in 8. So we put in 8, we're going to get 1 over 17. So we start at 1/17. That's a funky 7. 1/17, and then we have to put in 8 plus h. So what does that look like? So we're going to say 1 over 8 plus h plus 9, which is going to be 1 over 17 plus h. So we need to find the distance between those two. So in order to get an answer for that, it's going to be 1 over 17 plus h minus 1 over 17. So we need a common denominator of 17 times 17 plus h. This problem seems messier than it needs to be. What's missing here is 17, so we have a 17 in our numerator. What's missing here is the 17 plus h, so it's going to be minus 17 minus h. And so now we could subtract. And we're going to get negative h over 17 times 17 plus h. And then it says over the, remember the distance in the denominator was h, so we have to put h in the denominator. And that h is going to divide out with this h. So we're going to be left with, that becomes a 1. So we have negative 1 over 17 times 17 plus h. And that is okay that we have an h in our answer because the directions say, which write your answer with an expression involving h. Okay, on to 15. Now for 15, they give us a table, and they ask the average rate of change of G, the AROC of G, from 3 to 5. So that means our denominator is going to be a 2. We'll go from 3, which is a 1, to 5, which is an 8. Okay, so we went up 7 over 2, so that's how we can simplify it. So it's going to be 7 over 2 is our rate of change, or our average rate of change, or our slope. Moving on. So the function has a, let's see here, what are our choices? Minimum or maximum, so we're going to say that's a minimum there. And minimum value, so if the value is the actual y value, that's -4 there. And the x value, where it occurs, is at 1, x equals 1. The function is increasing on the interval, so it is increasing from 1 to positive infinity. So we'll say that's 1, comma, I need one of those special buttons. Infinity. Oh, I need to hit that button, don't I? Okay. Don't need that. So, and I don't want to waste time with it, so I'll write it over here. It's going to be increasing on 1 to infinity. That's positive infinity. And decreasing, this is increasing, and decreasing from negative infinity up to 1, and it's a soft bracket. Moving on. Looking at, what is this, 17 now? So in 17, increasing, so you could have more than one interval, so it's increasing from right here, -3. So increasing from -3 up until, looks like, up 0, like 1/2 maybe? I don't think expecting this to be perfectly exact. And the decreasing is going to have 2 intervals, looks like, from negative infinity to -3. And it's also decreasing from, I guess it's 1/2, if we had to approximate to positive infinity. There we go. And so just make a note that where it occurs is the x value, and what the min or max is the y value. So that's your min, that's your max. Where it occurs, 1/2 x 1/2 here and here, x is -3, just be careful between x value and y value there. Okay, I guess we have a maximum here. Local maximum right there at -3. So the value of, so that's the y value, at is the x value where it occurs. Looks like -3. The function is increasing on the interval. I don't want to waste time with the buttons on the computer, but it's going to be negative infinity up till -3. That's increasing, and decreasing is going to be -3 to positive infinity. And I think we're on 19 maybe. I'm not sure. Yeah, 19. Okay. So what do we got going here? This was decreasing. So where's it decreasing? So it looks like it's decreasing from negative infinity down to about 0, close to it. Really close to 0. A little bit before 0. And then right around 6 starts decreasing again. Or 5, a little after 5, right? So I'm thinking that one's probably a good answer right there, because it's negative infinity up to just before 0, and then decreasing from about a little after 5 down. So it looks like a good answer from there. Decreasing most of the function, actually. Decreasing, so where's decreasing? So decreasing from right around here, you find that local max. It's going to be around -2, not the y value, it's the x value where it's going down. So you see it's going down right here. See that, but then it's from -2 down to 4, like around approximately -2 to 4. So I'm going to say about that one. That one looks good. Now we have one of those word problems, okay? Like these application problems. We can handle it. Driver stops for gas. He looked at his watch, and the time was exactly 3:42 p.m. At that time, he pumped gas in there. At 3:46, the tank was full and noticed that he pumped 10.7 gallons. What's the average rate of flow of gasoline in his tank? Well, they just told you that it was 4 minutes. So 3:42 to 3:46. That's a change in x. That's 4 minutes. So that's our denominator, and our numerator is how much gallons of gas. They told us that's 10.7. So the driver pumps 10.7 gallons in 4 minutes, and that's all we could simplify it to. I think they want gallons per minute, so they do want us to divide that out. So we have to divide 10.7 by 4 to find out how many gallons per minute, because they say per minute over here. So it's going to be 2. You're going to get 8. You're going to get 2.7. And you're going to get, what's that going to be? It's a point here. 7, not 7, but 6. 24. So it's going to be 24, and you subtract 3, bring down the 0. 26.75. So it looks like 2.675 for that one. And that is sorry for that. Gallons per minute. So put that back, okay. All right, one sec. So in this function in this problem right here, they gave us the function, and you're supposed to use a calculator, graphing utility, in order to be able to approximate the local max of the function. But if you look at it on the graph, there's no real local max right here. It might be here, but it's not, because it keeps on going. So I don't think there really is a local max at all, to be honest with you. So I'd say DME for that one. It's not really a local max. All right. Looking back. Same with the local min, so graph it and then put your best guess in there what the local maximum are. That's the y values they're talking about right here. Increasing and decreasing. So look back here, intervals are so this is the increasing function everywhere. The y value is going up, except for maybe here. It slows down right at 0 for a little bit, so maybe negative infinity up to 0, and then 0 up to positive infinity, I would say, for increasing, and there are no decreasing intervals at all. And that's it for that one. So you just need a graphing tool to be able to describe that. So I hope this was helpful to you. Good luck, and email me with any questions or concerns.